Good afternoon, class. We are looking at Chapter 7, Trigonometric Identities and Equations, Section 7.1, Trigonometric Equations. So, this is Chapter 7, Trigonometric Identities and Equations, also known as Analytic Trigonometry, Section 7.1, Trigonometric Equations. We're going to continue with trigonometric identities, sum and difference formulas, double angle, half angle, product to sum to product, and solving more trigonometric equations. The objectives are solve equations involving a single trigonometric function using a calculator, using quadratic in the form, solving trigonometric equations using fundamental identities, and solving them using a graphing utility. Again, a quick reminder of what you've seen as far as fundamental identities are concerned. This is the format for the unit circle. This is the format when the circle has a radius r. And these are the identities I'm going to remind you because we're going to need them. Pythagorean identity, sine squared plus cosine squared equals 1. Tan squared plus 1 equals secant squared. 1 plus cotangent squared is cosecant squared. Quotient identities, tan theta is sine over cosine, cotangent is cosine over sine. Reciprocal identities, cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. Even and odd, f of minus x equals f of x is even, f of minus x equals minus f of x is an odd function. All trigonometric functions are odd except cosine and therefore secant. A periodic function repeats its value at regular intervals. Trig functions are periodic, k is an integer, and the period for all of them is 2 pi except tangent, which is pi, and therefore cotangent. Reminding you, if you want to graph a sine and cosine, a complete cycle goes from 0 to 2 pi. You cut that into 4 equal parts. From 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, and 3 pi over 2 to 2 pi, and evaluate the function at the end points, creating 5 key points and 4 arcs. Sine x is the same as cosine, shifted to the right by power 2, so cosine of x minus power 2. So the general format, if y is sine x or cosine x, period is 2 pi, amplitude is 1. If it's a sine omega x or a cosine omega x, period is 2 pi over omega, amplitude is absolute value of it. Reminding you of the inverse functions. None of the trigonometric functions are inverse because all of them are periodic and all of them fail the horizontal line test. Therefore, we have to restrict the domain in the case of a sine from minus pi over 2 to pi over 2, and therefore can find the inverse. Remember, domain of one is range of the other one when they have two functions that are inverse functions. So domain becomes the range for the inverse function, range becomes the domain. The graph looks like that. So the restriction put on sine is from negative pi over 2 to pi over 2. And that is resulting in f of f inverse being x. X belongs to sine x here, x belongs to sine inverse. So in this case, x is between negative power 2 and power 2, in this case between negative 1 and 1. In the case of a cosine, the restriction is between 0 and pi. And therefore, cosine inverse is created with the domain being negative 1 to 1, range being 0 to pi, and their composite function becomes x. In this case, the second one is cosine x, so x belongs to the domain of cosine here between 0 and pi. Over here, x belongs to the domain of cosine inverse from negative 1 to 1. The restriction on tangent is the same as sine, except the endpoints are not included, giving rise to the tan inverse. and their composite function is x. And again, in this case, x belongs to tangent between negative pi over 2 and pi over 2. And in this case, belongs to tan inverse, which is our real numbers. Now, secant, the restriction is just like cosine. Cosecant is like sine, and cotangent is actually like cosine. Of course, you have to pay attention to the vertical asymptotes and the point that gets excluded. All right. Let's go to the new stuff, 7.1, trigonometric equations. And as always, we should check the solution. Here's a simple example. Determine whether theta equals pi over 4 is a solution of the equation. And I'm reminding everybody of the 4 quadrants. Remember, in the first quadrant, everything is positive: sine, cosine, tangent, and the rest of it. In the second quadrant, the only thing positive is sine, and with that goes its reciprocal, okay, cosecant. In the third quadrant, tangent is positive, and therefore cotangent is positive. In the fourth quadrant, cosine is positive, and therefore its reciprocal, secant, becomes positive. And so we need to remember that. To solve this, we are going to move the square root of 2. We are going to plug it. Going to plug it. 2 sine theta, 2 sine of pi over 4. We know sine of pi over 4 is square root of 2 over 2. When we plug in, we get square root of 2 plus square root of 2, which is 2 square root of 2. It's not equal to 0. Therefore, this is not a solution. Let's see 5 pi over 4 works. We plug in 2 sine 5 pi over 4 plus square root of 2. Now, I want to remind you that the reference arc is pi over 4. Theta sub r, theta prime, depends on the text. And so it has the same value as this one, square root of 2 over 2, but based on the quadrant, you decide it's negative or positive, because you should know. In the third quadrant, sine is negative, so it's the same as square root of 2 over 2. The sine is negative, and therefore these two cancel each other. Negative square root of 2 plus square root of 2 is 0, and 5 pi over 4 is a solution, everybody. Two sine theta minus 1 equals 0. Move the negative 1. Make it positive 1 divided by 2. Sine theta equals 1/2. Sine theta equals 1/2 when theta is pi over 6 in the first quadrant. It is also positive in the second quadrant. So pi minus pi over 6. So on 0 to 2 pi, the answer is pi over 6. And the way you get that, this is in quadrant 2, because we should know sine is positive in quadrant 2. And the way you get that, it's pi minus the reference arc, pi over 6. And if we wanted the general solution, then we would add 2k pi or 2n pi. Move the negative, make it positive square root of 3, divide by 2. And cosine is square root of 3 over 2 when theta is pi over 6. The first quadrant. Cosine is also positive Let me use a different color. Actually, let me just. Also in the fourth quadrant. Therefore, it's 2 pi minus the reference arc pi over 6 if you take this as a reference arc. And that's how you get 11 pi over 6. Okay, everybody? And now you add 2k pi to make it a general solution. This is from 0 to pi, 0 to 2 pi in the first revolution, if you will. We want to solve this equation between 0 and 2 pi. The methodology when you have it's called multiple angles, meaning they just times some number, 2, 4, 5. The methodology is as follows. First and foremost, you solve as though it's tan of x, which means you are moving this one, and then you're dividing by square root of 3. And if you rationalize, you recognize this as the answer. First, I want to discuss the square root of 3 over 3 positive, and we see how we go to negative. You should know tangent is positive in the first and third quadrant, negative in the second and fourth quadrant. You should also know that the period for tangent is pi. So if we had tan x equals positive square root of 3 over 3, and x would become the angle that gives you the answer is pi over 6. However, when it's negative, that puts it in quadrant 2. Okay, and for quadrant 2, pi minus pi over 6 is 5 pi over 6. And also, if that's the case, also in quadrant 4, which makes it 2 pi. So quadrant, I have enough room here. Quadrant 4, 2 pi minus the reference arc pi over 6. That gives us 11 pi over 6. So we have those two answers. I wanted to show you how we get that. And again, we get that for x, which is 3 theta. The way you deal with 3 theta for all trigonometric functions, you add the 2k pi and then you divide by 3 and you plug in k from 0 all the way to this number minus 1. When it comes to tangent or cotangent, you can add n pi. Okay, and divide by 3. So if I'm dividing everything by 3, that means this becomes theta, this becomes 5 pi over 18, this becomes n pi over 3, this becomes 11 pi over 18. Because the period for tangent and cotangent is pi, the easiest way is to go with that and choose n from 0 to 5. Why is that? Because this is 3. In the case of a tangent and cotangent, 2 times 3 minus 1. If it was, let's say 2 times 2 minus 1, okay? But you start from 0. So if this is the fastest way, class. Plug in 0, you get 5 pi over 8. Plug in 1. Remember, 1 means pi over 3. And let me just write that so everybody can just know this. So remember, pi over 3 is something over 18. So it's 6 pi over 18. So if I plug in 1, this much I'm adding, I get 11 pi over 18. If I put 2, I add 1 more of this, 17 pi over 18. If I put 3, I add pi. Remember, pi is what? 18 pi over 18. Okay, 18 and 5, 23 pi over 18, and 29 pi over 18, and 35 pi over 18. And these are the answers. Fastest way is to go with this one. And by the way, it's really good practice to check them out. All right. I noticed first and foremost on this page, I wanted to emphasize different quadrants and what's positive, what's negative, okay. And I gave you all kinds of stuff, and I figured you figure out what's the fastest one to help you remember. Would that help you remember? Would that help you remember this one, this one, this one? I don't know. I figured I put them all there, but you really they don't need all of them. They all mean the same thing. And in short, um, in the first quadrant, all are positive. In the second quadrant, sine is positive, which makes cosecant positive. In the third quadrant, tangent is positive, which makes cotangent is positive. In the fourth quadrant, cosine is positive, which makes secant positive. And how do you remember that? Associate cosine with x, associate sine with y. That's all. So first and second quadrant, y is positive, so is sine. First and fourth quadrant, x is positive, so is cosine. And then the rest of them follow accordingly. And of course, tangent is sine over cosine, so when they have the same sign, it's positive. So even in the third quadrant, tangent and cotangent become positive because both sine and cosine are negative. Negative makes it positive. All right, so we want to solve this. Cosine of x is 1, let's say. So it must be 0 or 2 pi, but pay attention, we don't have the equalities, just we want one of them. By the way, 0 is ultimately the same as 2 pi. So that means x is 0. That means theta minus pi over 4 must be 0, and that makes theta equals pi over 4. Multiple angle. Pay attention to the fact that it's a multiple angle. Sine 2 theta is 1/2. And again, assume it's x. That means x is pi over 6 and 5 pi over 6. There are two answers. I've already explained how you arrive at it, remember. Sine is positive in the first quadrant, so pi over 6. In the second quadrant, pi minus pi over 6 gives you 5 pi over 6. I've shown that a couple of times. So by now we should be comfortable. And since it's a multiple angle in a complete revolution from 0 to 2 pi, you have to add, in the case of a sine, 2k pi to figure things out. So you add 2k pi. Then you divide by 2 because you're solving for theta. So we are going to divide by 2. So this one becomes theta equals pi over 12. Remember, when you divide a fraction by a number, you multiply the denominator by it. Plus equals pi over 12 plus k pi. And the second one, theta, is 5 pi over 12 plus k pi. And the way it works, this number, call it n. So you choose k equals 0 and 1. In other words, you go all the way to n minus 1 here. If this is 5, you go from 0 to 4. If it's 7, 0 to 6. If it's 3, 0 to 2. Because it's 2, 0, and 1. What happens if you choose 2? It repeats. I'll quickly show you. So if you plug in 0 here, you get pi over 12. And if you plug in 0 here, you get 5 pi over 12. So that's clear. Let's plug in 1. If you plug in 1 here, this is pi. And pi is what? 12 pi over 12. So you get 13 pi over 12. And if you plug in 1 here, this is 12 pi over 12 with 5, 12 and 5, 17 pi over 12. Now, if you plug in 2, class, here's what happens. If I plug in 2 is 2 pi, it goes beyond a complete revolution, the same here. That's why you stop at n minus 1. For sine n theta, same thing for cosine n theta. Okay? This is extremely important to understand. That's how you deal with multiple angles. We want to solve trigonometric equations, quadratic in form, meaning you're dealing with a quadratic equation. You know how to factor if need be, use the quadratic formula. In this case, 2 cosine squared theta minus cosine theta minus 1 equal to 0. And we want to get the answer from 0 to 2 pi. So you have a choice. You can say, okay, let's say this is x. If so, you have 2x squared minus x minus 1 equal to 0. Or just factor the radius. So if you want to go with that, class, you have x, you have 2x, because 2 is a prime number. And negative 1, you have no choice but to put both of them one of them negative. Now, which one? You have to check the middle term. So if I put plus 1 here, minus 1 here, look, this is 2x. This is minus x. Okay. And they add up 2x and minus x, they add up to x. And that is not working. Not working. Why? Because the middle term didn't work. So you have to go with minus 1 here, plus 1 here. Now look at this. This is x. This is minus 2x. They do add up to the middle term of minus x. So that's how you factor this. Very straightforward, everybody. Now, do I have to go with the substitution to x and do it? No, if you can do this, you don't need that, okay? So either this one, so 2, look at this one, 2x plus 1, 2 cosine theta plus 1, x minus 1, cosine theta minus 1, right? You see that? Let me erase my work. So either this one is 0 or this one is 0. If this one is 0, cosine theta is negative 1/2. If this one is 0, cosine theta is 1. This one just has one answer, 0. Cosine 0 is 1. And remember, first, again, let's go with the reference arc and 1/2. I want to make sure that we understand how we handle this one. So assume cosine is positive 1/2 and theta becomes pi over 3, or better yet, theta of sub arc, the reference arc. But negative, cosine is negative in the second quadrant and in the third quadrant. In the second quadrant, pi minus the reference arc. In the third quadrant, pi plus the reference arc. So the answers are 2 pi over 3, 4 pi over 3. The other one we established is 0. So those are the 3 answers. Again, whenever it's negative, make it positive and find the reference arc so you know what to do. Solve the trigonometric equation using identity sine squared minus sine theta equals cosine squared theta. The moment you hit that, where you have sine squared and cosine squared class, okay, you use the Pythagorean identity, one of those, to change one of them. Either change this one to 1 minus cosine squared, or change this one to 1 minus sine squared. Because this is sine theta, we're going to change this one to 1 minus sine squared. Okay, everybody? Because the sine theta we don't want to change, we are going to use this. Okay? Cosine squared is 1 minus sine squared. I'm assuming we are comfortable with the identities, everybody. And so this moves, with this one becomes 2, this moves and becomes negative. And this is similar to what we just did. You have to factor it. The factoring, again, you can go with 2, let's say x squared minus x minus 1 equal to 0, and factor this, or just factor it the way it is. It's a simple factoring, 2 sine theta plus 1 times sine theta minus 1, again, simply because this is a prime number, okay? And of course, 1 is just 1 times 1. One of them has to be negative. It's just very straightforward, I believe. Pretty much like the previous page in essence. So sine theta is negative half here, and it's positive 1 here. And we are going to solve. This is again easy. Sine theta is 1 when it's pi over 2. By the way, if they say 0 to 360, you would answer 90 degrees here. But when they say 0 to 2 pi, you have to answer it in radians. Pay attention to what they are asking you. And so it's pi over 2. Negative 1/2, I'm going to do the same thing again. I'm going to go with 1/2. I'm going to say, okay, if sine theta was 1/2, then the reference arc would be pi over 6. Okay, but it's negative 1/2, which means either quadrant 3 or quadrant 4. In quadrant 3, we add pi to reference arc. In quadrant 4, we subtract the reference arc, pi over 6, from 2 pi, results in 7 pi over 6 and 11 pi over 6. So I'm showing you the methodology that you can easily get to the answer. And the last one is pi over 2. This is, and again, the way you answer it, take a look at what they have given you. All right. Three sine squared equals cosine squared. We are going to use the identity sine squared plus cosine squared equals 1, and therefore change one of it. And since this one has 3, maybe we change this one to 1 minus sine squared. Sine squared plus cosine squared equals 1. It's one of those Pythagorean identities. You should be very comfortable. And so we're going to move things around as follows. We are going to move this way, make it plus. And therefore, we have 4 of them. And so divide by 4. And take a root. So sine theta is plus minus square root of 1/4 or plus minus 1/2. And we've done this before. Sine theta equals 1/2. Back to example 2. We should know the answer is pi over 6 and 5 pi over 6. And sine theta equals negative 1/2, the same reference arc, namely pi over 6. And in the previous page, we showed that the answers are 7 pi over 6 and 11 pi over 6. So this is from the again, I've explained that. from the previous page. This is in the beginning. So there are 4 answers, therefore. We're going to move on. Again, we notice we have cosine and sine squared. Because this is cosine theta, degree 1, we're going to change the sine squared to 1 minus cosine squared. And since we want to solve a quadratic equation, we move everything to the same side, namely the left side. So therefore we get plus 2 cosine squared theta minus 2. And so we put it in descending order. 2 cosine squared theta plus 3 cosine theta plus 1. Again, it's a very simple factoring because 2 is a prime number and 1, you have no choice but to go 1 times 1. Both of them have the same sign. Either both of them are positive or negative, and this actually indicates that both of them are positive. So 2 cosine theta plus 1 times cosine theta plus 1. I'm assuming we are very comfortable with factoring class. Again, it's a prime number. Okay, so you would start writing 2 and 1 here, and then figure out what you need to put there. All right, in the first case, cosine theta, if you set this equal to 0, cosine theta becomes negative 1/2. In this case, becomes negative 1. So if you go back to the notes, I explained how you solve that. First, you go with the reference arc. Cosine theta is 1/2. You figure out reference arc. Again, I write it, but just to refresh your memory. So cosine theta is positive 1/2, and that gives reference arc of pi over 3. And since you want it to be negative 1/2, it's in the second and third quadrant. Pi minus pi over 3, pi plus pi over 3. Those are the answers. Cosine theta equals negative 1 under one condition, theta being pi. So we have the answers, and we are done. Pretty straightforward, everybody. Again, between 0 and 2 pi. Remember, you add 2 and pi in the case of a sine and cosine if it's not. So we want to solve this, and we notice on the right side we have 3 times cosine theta plus 3. The left side is sine squared. So we use the Pythagorean identity, sine squared plus cosine squared equals 1. Change this to 1 minus cosine squared. As since we want to put this in descending order and all on the same side, we move this one becomes positive cosine squared, and we move this one becomes minus 1. So we get cosine squared plus 3 cosine theta plus 2. And Definitely, that's an easy factoring. You want, so the coefficient here is 1. So it's cosine theta and cosine theta, and you want two numbers. The product is 2, the sum is 3. So those are 1 and 2. So that's very straightforward, everybody. So cosine theta is either -1 or -2. This one we've already established is pi. Cosine theta can't be -2. Cosine theta is between -1 and 1, including -1 and 1. So that's out. Okay, everybody. Cotangent square is 3/2 cosecant theta. To solve this equation, we have to relate cotangent and cosecant, and we remember one of those Pythagorean identities says 1 plus cotangent squared is cosecant squared. We are going to use that, which means we are going to change this. To cosecant squared theta minus 1. Why do we change it that way? Because this side has cosecant theta. So we change that to cosecant squared theta minus 1. And since we don't want to deal with fractions, we are going to multiply everything, both sides of the equation, by 2. So what happens? This becomes 2 cosecant squared. This becomes minus 2. This becomes positive 3 cosecant theta. This one we move and it becomes negative. So we have 2 cosecant squared theta. Maybe I write the previous step. So we have 2 cosecant squared theta minus 2 equals 3 cosecant theta, and this moves. And now it's a prime number. I would set it up as 2 cosecant theta and cosecant theta. And then since this is -2, that means I need 1 and 2, and one of them must be negative. So you do the trial and error. This is what you end up. Please understand, the product of these two is 1 cosecant theta. The product of these two is -4 cosecant theta. And they do add up to -3 cosecant theta. This is how you check. You check the middle term. So cosecant theta is either -1/2 or +2. Now we don't remember the values for cosecant, but we know cosecant is the reciprocal of sine. So instead of looking at this, we are going to look at sine and reciprocal these two. The reciprocal of this is -2. The reciprocal of this one is 1/2. And this we know has no solution because sine is between -1 and 1. And this we know the answer is power 6 and 5 power 6. So again, from cosecant, we go to sine because we are familiar with those. Now let's solve an equation with the calculator. Solve and round to 2 decimals. Cosine is 0.2. Obviously, that's not a common arc, and we have to figure it out using a calculator. So if cosine theta is 0.2, theta is cosine inverse of 0.2. We write it in this fashion. We put it into a calculator. And it gives us 1.3, and they said 2 decimals, so number 6. Next to it is 9, so 1.37 radians. Now, remember, cosine inverse gives you a unique solution, so just one solution. But from 0 to 2 pi, there are 2 solutions, and you do know this acts as the reference arc. So this would be the reference arc because it's in the first quadrant, or because it's between 0 and pi over 2. And by the way, how do you know it's between 0 and pi over 2? Remember, pi over 2 is about 1.57, right? Half of 3.14, roughly. And so, you know, cosine is positive in the first and the fourth quadrant. And how do you get to the fourth quadrant? 2 pi minus the reference arc. For inverse cosine, the calculator will only give you an angle from 0 to pi. There's another angle in the interval from 0 to 2 pi with that cosine value in quadrant 4. Why do we say quadrant 4? Because this thing is 0.2 is positive, everybody. That's the reason. Quadrant 4, because it's positive. So subtract it from 2 pi. So this is the given 1.37. The blue one is the given. And the red one, 2 pi minus 1.37 is 4.91. This is how you get to the second one. Solve and round to 2 decimal places. Tan of theta is negative 2, and we want it in the first revolution from 0 to 2 pi. So if tan of theta is negative 2, that means theta must be tan inverse of negative 2. Now, tan inverse of negative 2, you put it into a calculator, gives you the answer. And you want 2 decimals. So this is the second one. Next to it is 7. So 0 goes up to 1, becomes negative 1.11 radians. All right. Now, again, any inverse, tan inverse, cotangent inverse, sine inverse, cosine inverse, you get one answer. But there are 2 answers. Tangent is negative in the second and the fourth quadrant. So negative 1.11 puts us in the fourth quadrant. This is the fourth quadrant because it's negative. So if you add pi, puts you into the second quadrant. So for inverse tangent, The calculator will only give you an angle from negative pi over 2 to pi over 2. Remember the restriction that was put in there. There is another angle in the interval of 0 to 2 pi with that tangent value in quadrant 2. Theta is pi minus 1.11, 2.03 radians. 2 pi minus 1.11 is 5.17 radians. Because we want to go from 0 to 2 pi class, you add pi, it gives you in the second quadrant. You add another pi, it puts you in the fourth quadrant, and it becomes positive because we went from 0 to 2 pi. So to this number, add pi, puts you in the second quadrant. Add another pi, that's why pi and this one, 2 pi and this one. So the answer was negative 1.11. Okay. You add a pi. So to this one, you add a pi and gives you this angle because one is positive. And then you add 2 pi, gives you this angle. So the answers are 2.03 and 5.17. If we didn't care that it was negative, one of them would be negative 1.11. But we do. So if it's negative, you change it accordingly. This is how you deal with tangent. Simply add pi and 2 pi to have answers in the interval of 0 to 2 pi. That is the fastest and easiest way to think about it. Just add pi and 2 pi. That's all. You have the answer, add pi and 2 pi. Okay. Solve trigonometric equations using a graphing utility. Solve and round 2 decimal places 3 cosine x plus x equals 4. So we can't solve this just the way we did before. This cannot be solved by previous methods, but can be solved using a graphing utility, meaning you can put this one as y1, this one as y2, or move things around. You can even move the x and say one side is 3 cosine x, the other one is minus x plus 4. However you put that, that's fine. So you put y1 equals one side, y2 equals the second side in a calculator. You graph it. This is the first one. This is the line, horizontal line, y equals 4. Point of intersection is the answer. And the way you do it, use intersect to find solutions. In other words, you go to TI calculator, you press calc, second trace, and you follow these steps that I have here. So you go to the calculator. Okay. So calculate, you go to intersect, and then you move things until you hit this point. For the secondary, so it gives you 4.53. So that's how you deal with the calculator. Two sine squared theta minus 3 sine theta plus 1 equals 0. Again, we are dealing with trigonometric equations that we can use the quadratic formula, quadratic format to factor this. And in this case, you don't have to make any changes because all of them are a function of sine. So this is like 2. Again, if you want, you can write 2x squared minus 3x plus 1. And again, you want two numbers, the product is 2. So 2 and 2 sine theta and sine theta, and positive 1 would be negative 1 and negative 1, or positive 1 and positive 1. Since this is negative 3, both of them are negative 1. Okay. And so you factor them into this. 2 sine theta minus 1 is 0, or sine theta minus 1 is 0, and this gives you sine theta equals 1/2. This gives you sine theta equals 1. Again, this is very, I mean, we've done this before. This is power 6 or 5 power 6, and this is power 2. We had done this before. There is nothing brand new here, class.